Hello everybody. Today we start with a new chapter in mathematics in standard 10th ICSE, that is heights and distance. Now the chapter heights and distance is a chapter which is based on the applications of it is based on the application of trigonometry. So we very well know that in trigonometry we are going to be using a right angle triangle, and wherein this will be the angle theta here and this is the opposite side to the theta, this is the adjacent side to theta, and this is the hypotenuse to theta of this triangle. So this is 90 degrees, and we know that the three main ratios of the trigonometry are sine theta, that is we'll take it sine only, short forms, sine theta, cos theta and tan theta. And we also know that these are ratio means sine theta is opposite upon hypotenuse, cos theta is adjacent upon hypotenuse, and tan theta is opposite upon adjacent. So these are the three main ratios of trigonometry which would require in this chapter. We won't require cosec, sec and cot, which are the reciprocal of these. We'll just require these general ones. And to remember these ones, if you remember in the 9th standard, we had said that we are using a wording which is called as Osha Chota. Okay, what is Osha Chota? Osha Chota is nothing but sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. So once you remember the word Osha Chota, automatically you are remembering these ratios by heart. So this is how we are going to remember it, that Osha Chota will be sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. These are the three ratios which will be requiring in this particular chapter for the applications of the trigonometry. So first one was this part. We will also require to remember the we may also require to remember the table what we were using for the sin 30 cos 60 45 वाला जो था वो भी याद करने का ज़रूरी है. तो accordingly we'll just recap that one also. So if you remember, it was this way that I have got the sine, cos and tan of theta, where theta was 0, 30, 45, 60 and 90. We just wrote over here as 0, 1, 2, 3, 4. We divided everything by 4 over here. So you divide everything by 4, and then you are taking the square root of these. So square root of these are going to be taken. Accordingly, the answer over here will be 0. So sine 0 is 0. Sine 30 will be 1 upon 2, because 1 ka square root is 1, 4 ka square root is 2. Sine 45 is 1 upon 2, the whole which is 1 upon root 2, and this will be root 3 upon 2, and this will be 1. So this is how you are getting the value of sine 0, sine 30, sine 45, sine 60, sine 90. And accordingly, cos is just the reciprocal ulta of this. So 1 comes here, then root 3 upon 2 comes here, 1 upon root 2 is here, this is 1 upon 2 coming here and 0 coming here. So that is the value of cos. For the value of tan, it is not, we know that sine upon cos is nothing but 10. So accordingly, sine upon cos, 0 upon 1 will be 0. This upon the 2 gets cancelled, will be 1 upon root 3, 1 upon root 3. Then this will be 1, this will be root 3, and this will be infinite, or we can say not defined. So this table also will be required by you to because you may be given some values of the angles and you need to know that tan theta is this much, cos 60 is this much. You may require that thing. So that is why you will require this table also to be learned properly. Okay, that is these two things. The next thing what we may require is to understand how to find out the values of another angles other than these angles using the table. So the table what you are using over here is given in the back of your textbooks. On the back side of your textbook, just before the answer section in Concise as well as ML Agarwal, both cases, in fact any book, you will find that just before the answer section, there is these tables of natural cos, natural sine and natural tan. Okay, this is natural sine ka, upar likha hai natural sines. Then you have got over here natural cosine and that is natural tangents. So sine, cosine and tan are what you are having over here. So natural sine, cosine and tan. How to read this is very simple. Suppose you want to find out what is sine 35. So this is 35, or you just look for 35 in the first column. So 35 over here is like this, and then sine 35 is 0.5736. Okay, that is sine 35. If it is given as sine 35 and 30 degree, the 35 degree and 30 minutes. So you can see over here it is 0, 6, 12, 18, 30. ऐसे करके minutes में भी दिया है और even points में भी दिया है. So minutes and points both are given over here. So accordingly, if you want sine 35 and 30, so it will be sine 35 and 30 will be over here, which will be given as 0.5807. Okay, this is more than sufficient. You will not require this part right now, so we will not discuss that thing. So anyways, whatever the values which will be given you will be easily available in this particular manner. Similarly is in cos also. Cos ka value, like if I say cos 75, so cos 75 is here, 75 is here. It is 0.2588, that is cos 75. If I want, let's say cos 55.7 degrees, so it is 55 is over here and 7 is over here, 0.7 is here. So 55.7 will be given as 0.5635. Okay, this is how we are going to get the values of the tables. And lastly, the most important part is 10 ka part, also the same way. So 10 ka part may also, like if I want to find out what is 1035, so 1035 is over here, it is 0.7002. If I am asked it is 1075, so 75 is here, it is 3.7321. If I am asked is 1055.50, so it will be 55.0.5, so 55.5, so it is 55 and 0.5 will be 1.4550. So in this way, this is something what you will require, because you will be having the triangle. So what will be there is, you may be having this triangle wherein this theta may be given to you, and you are told one of the side, out of the three, one of the side is given to you. Suppose the side given to you is here, this is 10. Okay, and the theta is given to you as 37 degrees. If I want to find out this side, that is, if I want to find out AB, then you know that this is the adjacent side, this is the opposite side. So I can use tan theta. So tan theta is going to be AB upon BC. So tan theta is tan 37 is equals to AB upon BC is 10. So tan 37 we get the value from this table as 0.7536. So it is 0.7536 into 10 is equals to AB. Therefore AB will be equal to 7.536 centimeters. This is how we are going to get the value of things like this. Similarly, suppose I want to find out AC also, not through Pythagoras. Why should I use that? So in that case, what will happen? I will be taking the next formula as cos theta is equals to BC upon AC. So that's why we know that AC over here will be AC is equals to BC upon cos 37. So that will be 10 upon cos 37. We just find out the value of cos 37 from the table as 0.7986. Okay, so you just divide this thing. Yeah, of course a tough one, but yes, you need to divide this thing and get the answer over here. In the questions, we'll give you another method of how to do this particular sums. Oh, okay, I'll explain you here itself how to do such sums. Fine, let it be. Okay, because we will not be able to do in this case. The example what I given is not the right one to show this thing. Okay, so you will find that in such a way you are able to find the sides of the triangle if you know one of the angle and one of the side of that right angle triangle. So this is the basics of the trigonometry which we'll be using in the heights and distance chapter. Now comes the main part of the chapter, and that is how to identify or what is to be seen in a particular sum. So what are the things what we see in a sum in case of the heights and distance chapter. So we see that always in case of a heights and distance chapter, there will be one observer and there will be objects. Okay, it will be such that the observer and the object will be placed at places which will not be in the same horizontal plane. Because same horizontal plane में होता तो वो सीधा distance हो जाएगा. Okay, it will be such that, like for example, if the observer is here, but he is looking at a top of a building which is over here. Okay, so this observer looks at this object. This is the observer, and this is the object. So when the observer looks up, when anybody looks up, okay, the angle what he makes with the ground is called as angle of elevation. Okay, what is angle of elevation? Angle of elevation is angle between ground and or angle made with the ground when looking upwards. Angle made with ground while looking upwards. Very important, upwards. If I am looking up, the angle which I make with that particular thing is the angle of elevation. So over here, this theta is the angle of elevation. This is angle theta. Right? Similarly, if somebody is standing at the top and he is looking at some object which is over here, looking down like this, then the angle which he makes with the horizon, okay, here it is with the ground, here is the horizon. So the angle which he makes with the horizon, this is called as angle of depression. So angle of depression is angle made with horizon while looking downwards. So whenever the observer is at a particular height and he looks something down, then he is going to make an angle of depression with the horizon. And you know that the horizon and the ground will always be parallel to each other. Accordingly, by the alternate interior angles, this angle will also be the same. So while drawing the figure, you have to draw this way, but while calculation, you will be taking this theta as the same as this one. Okay, while calculation. So it will depend upon the sum to sum, it will depend upon sum to sum, but whenever you are going to use it, you can use this angle is equal to this angle because they are alternate interior angles, as horizon is always parallel to the ground surface. So this is the two important things what you remember in case of heights and distance, and that is angle of elevation. So angle of elevation is when you are looking upwards. When you are looking upwards, what you make is the angle of elevation. When you are looking downwards, what you make is the angle of depression. Okay? Looking downwards, depression. Upwards, elevation. Remember this thing? So that is what you see is the main part of this particular chapter. So accordingly, the most important thing in this chapter is to understand the question. First of all, what is required is to understand the question. And once you understand the question, you will have to draw. It's compulsory to draw a diagram to represent that condition. Like if it is given that a person is standing in front of a tower and he is looking upwards, so you have to draw this figure saying that this is the person who is looking upwards at the object on top of a tower. This is the angle which is making over here. He is standing so at such a distance from the tower is what will be given to you. You can find out the height of the tower. Or suppose the person is standing on the tower and a ship or a car is coming near towards the tower, and then when he looks at the car, he makes an angle of depression. Then you are going to draw this figure to show this particular kind of the figure. Okay, question. Got it? So important thing over here is to understand the question, draw a related figure to this thing, and then calculation. See, calculation will be easy. It will be hardly 2 or 3 steps. Because it will be just simple thing like tan theta is equal to AB upon BC. तो AB मालूम है, theta मालूम है, tan theta मालूम है, उसका calculation किया, BC का value ढूंढ लिया. Right? So, calculation may not be that difficult, but understanding question, drawing the figure accordingly is more important. If you draw the figure wrong, and even if the answer is right, you get it completely wrong, because that means that you have not understood the question. You are told that the person is standing here and he is looking at this thing and you are drawing a figure like this, then it is wrong because the person was here. So you have not understood the question. No doubt, the thing is going to remain the same because this angle and this angle is going to be same. But till the time you do not show the horizon here and you do not show the angle over here, you are not getting full marks. So that's why you have to be very careful while doing these sums. You need to understand the sums properly, to understand the question properly, and then do the sums. So we'll now start with the exercise 22A so that we can understand this chapter much better. So we start with the exercise 22A. Okay. The height of a tree is √3 times the length of its shadow. So, what you see that the height of the tree is √3 times the length of its shadow. Find the elevation of the sun. So, we can see that this is a tree. We are not going to draw anything like a tree and everything. We are just going to take a single line to be the tree. And we very well know that if the sun is over here, then the shadow is going to be such that it is going to be like this, that the shadow will be over here. This is the shadow. So we can see that the shadow, this is the tree, this is AB, and BC will be the shadow. It is given that the length of the tree, height of the tree is √3 times the length of the shadow. If this is x, this is √3x. Okay, so you can see AB is equal to length of tree, BC is equal to length of shadow. So this is x and this is √3x. So now we know we want to find out the angle of elevation of the sun. That means this angle is what we are talking about. So if at this particular point, if I want to see the sun, what is the angle at which I will need to see the sun? So that is the angle of elevation we are talking about. So theta is angle of elevation. Therefore tan theta is going to be AB upon BC. So that is nothing but AB is √3 upon x. So x's get cancelled. So accordingly tan theta is equal to √3. What is √3? Then what is √3? Tan 60 is √3. So tan 60 is equals to root 3. Therefore, theta is equals to 60 degrees. So the angle of elevation is 60 degrees. So this is what we are seeing in the first question of exercise 22A. Yeah. Okay, we know next to the right. Now we move on to question number 3. A ladder is placed along the wall such that its upper end is resting against a vertical wall. The foot of the ladder is 2.4 meters from the wall and the ladder is making an angle of 68 degrees with the ground. So it is given that this is the wall. Okay. This is the ground. So the ladder is placed at a distance of 2.4 meters from the base of the wall and it is making an angle of 68 degrees with the ground. Okay, this is the figure. See, what is important is the figure. Find the height up to which the ladder reaches. So you need to find out this h. Let's get as A, B and C. AC is the ladder. AC is ladder. Okay. And accordingly we see that 2.5, the foot of the ladder is showing 2.5 meters. So we know here that tan 68 degree is equals to AB upon BC. Therefore tan 68, we'll use the table to find out. Yeah, the table is also found in such log table book. So in the log table book, you have to be very careful because there are two things over here. One is the natural sine and cos and other one is a logarithmic sine and cos. So you have to see the natural one only. Okay. Such a book will be given to you in the board examination as well as during the examinations in your schools. So that's why you need to, not this particular book, but such block table book, maybe one orange color one and the other ones are there. So you need to see only the natural tangents, not the logarithmic tangents. So the natural tangents, in natural you are looking for 68. So the 68 in natural tangents is available over here as value is 2.4751. It is 2.4751 is equals to AB upon 2.4. Okay, so that is the thing. So therefore AB is equals to 2.4751 into 2.4. Accordingly the answer, so it is 24751 into 24 is 4 for the 20, 28, 30, 4 for 16, 17, 18, 19, 8 and 9. Okay, so this is 0, 2s are 10s are 14, 15s are 8s are 9s are and 4s. Yeah, that is 4204915. That is 5.94. So it will be 5.94024 meters. That's nothing but 5.94 meters. So the height what it could reach, the height to which the ladder could reach, the top will be 5.94 meters. Okay, so that was sum number 3. Up till now, quite easy sums. Yes. So we move further to sum number 5. Sum number 5. A kite is attached to a string. Find the length of the string when the height of the kite is 60 meters and the string makes an angle of 30 degrees with the ground. So it's a simple thing. There is a kite over here and this kite is having a string which is like this and it is making an angle of 30 degrees with the ground. and the length of the height of the kite, this height of the kite from the ground level is 60 meters. So the kite has gone to a height of 60 meters, and the angle which is making with the ground is 30 meters. You need to find out what is the length of the string. So this length of the string is what you need to find out. We can call this as A, B and C for convenience. Accordingly, you can see that this is 30, so this will be opposite side in hypotenuse, yani sine 30. So we have over here that sine 30 is equals to AB upon AC. So sine 30 is 1 upon 2 is equals to AB is 60 upon AC will be AC only. So AC is equals to 60 into 2 is equals to 120 meters. So yes, we see that the string required, the length of the string required will be equal to 120 meters. So you can see very easy sum. So that is the sum number 22. Sum 22A, fifth sum, 120 meters. So that is question number 5. You can see very easy. We move on to question number 7. Okay, question number 7. The upper part of a tree broken over by a wind makes an angle of 45 degrees with the ground, and the distance from the root of to the point where the top of the tree touches the ground is 15 meters. What is the height of the tree before it was broken? So it is this way, that suppose this is a tree, okay, and it broke from between somewhere, and then this part fell down. So this part fell down like this, such that it is making, so it is given that it is making angle of 45 degrees. So the angle what is making, this particular thing is making, so this part has broken and fallen down over here. So this is equals to this. And yeah, the distance from the root to the point where the top reaches is 15 meters. It's given that this is 15 meters. So we can take this as point A, B, C and D. Okay. So we see that AB is equals to BD. That's the broken part of tree. Okay. We need to find out BC plus BD. What we need to find out is find AC, which is nothing but BC plus BD. Right? So for this thing, first of all, BC, we'll take it as tan. So tan 45 is equals to BC upon CD. Tan 45 is 1 is equals to BC upon 15. Therefore, BC is equals to 15 meters. So this is 15 meters. Now, we take the BD. So it is tan, not 10. Now it will be, obviously, sine 45 is equals to BC upon BD. Therefore, BD, or we can say sine 45 is 1 upon root 2 is equals to 15 upon BD. So therefore BD is equals to 15 root 2. Okay, 15 root 2 is nothing but 15 into 1.414. So it is 1.414 into 15. So that will be 15 4s 60. 15 by 15, 21, 15 by 60, 62, 15 by 15 plus 6, 21. So that will give me the answer to be as 21.21 meters. We need to find out the height of the tree. So therefore, height of tree unbroken is equals to AC is equals to BC plus BD is equals to 15 plus 21.21 is equals to 36.21 meters. So the height of the tree will be 36.21 meters for sum number 7. Is it clear? You can see it's decently easy sum, not too much of a problem. We are just using sine theta, so yeah, degree sign is important here, and you are getting the answers. Okay, so we'll continue with sum number 9 in the next video.